I welcome you all for today's class on beta angle problem. So the problem which I am going to explain is on equilateral triangular lamina. The problem states like this. An equilateral triangular lamina of 25 mm side lies on one of its sides on HP. The lamina makes 45-degree with HP and one of its median is inclined at 40-degree to VP. Draw its projections. So how to solve this problem? So we have to go step by step. In the previous class, I explained how to go with it. So first identify the position in which it lies. Next, identify the surface inclination. Next, go with line inclination. So these are the three conditions which I have explained. So by seeing this, how the equilateral triangular lamina is lying. So it is lying on one of its sides. Where it is lying? It is lying on HP plane. Next, the lamina makes 45-degree with HP, means it is a surface inclination. So surface inclination is with respect to HP. So draw a equilateral triangular lamina on HP plane such that the side is resting. So this is the first condition in which we have to draw the equilateral triangular lamina. So I will draw a equilateral triangular lamina of 25 mm length. So whose adjacent angle is 60-degree. So I will represent the equilateral triangular lamina and name it as A, B and C. But in this problem, he has also mentioned a median is inclined at 40-degree to VP. So I have to mention the median. So what do you mean by median? So the midpoint of a line, right? So I will mark the midpoint of this line and I will extend it up to the point C. Right. So I will name that as D1. Next, I will project the line upward and I will get the front view of this equilateral triangular lamina. So I will name it as B dash in the bracket A dash, because when I see from this direction, so B point is visible whereas A is hidden. So I will represent in the bracket. Whatever the things it is hidden. So next the point C is been represented here. So it is C dash. Okay. Next, coming to this second position of front view by seeing the surface inclination. So it is inclined at 45-degree to HP, means that will be seen in VP plane. So I will draw a line of length, whatever the length I have got here, the same length I will take and I will draw a line at an angle of 45-degree. And the naming as usual, it is B dash in the bracket A dash and here it is C dash. Next I will extend the line downwards. So A dash, A inclination will get point A, similarly B dash and B inclination will get B, C dash and C inclination will get C point. So I will join the line and I will get this second position of top view of an equilateral triangular lamina. So how it differs from the normal problem to beta angle problem. So we can see here he has asked that one of its median is inclined at 40-degree to VP. So a line inclination, right? The third point is a line inclination, but he has not given the edge. He has given the median is inclined at an angle of 40-degree. So one thing what we have to analyze is if it is edge inclination, the length of this 25 mm will be same here, 25 mm. So it is not changing the length. So it becomes the normal problem. Whereas you can see here the median, with respect to median, the length of this D1C will not be same in this view D and C. So at that condition it becomes a beta angle problem. So we have to represent in such a way that it differs from the normal problem. So first what we have to do is we have to draw a line of 40-degree line. Next, mark a point C on that 40-degree line. Next, measure the distance from C to D1 and cut an arc. Next, draw a locus of D point. After that, from the same point C, I will measure this distance C and D and I will cut a line on the locus line. So then I will join the point C and D. So we got the point C and D. So we have to mention the point A and B. So for that I will measure the distance from C and A and I will cut an arc. Similarly I will measure the point from C and B. I will cut an arc. Next from D and A I will cut an arc. Next from D and B I will cut an arc. So I will join the intersection points from B, D and A. So I will get a triangle. Next step is similar to the previous problem where I will project the line upward from A to XY line, from C to XY line, next from B to XY line. So intersection point is from A to A dash, from C to C dash, next B to B dash. Next I will join the lines and thereby we will get the final position of the front view of this equilateral triangular lamina, which is been inclined with some angle with respect to the reference plane. So that is how we have to solve. Now we will learn how to draw it manually. First draw a line, XY line. Next name it X, Y. As we are following the first angle projection, the VP plane will be above XY line and HP will be below XY line. Now we have to draw the equilateral triangular lamina, right? So based upon the condition, we know that it is lying on one of its sides. So the line will be drawn first because it is the side right side representation of a lamina. Next, we know the exterior angle is 30 degree for equilateral triangular lamina. So measure in protractor 30 degree and place it of a length 25 mm. Next join it. Because it is the view, the line should be made dark. It should be visible. Right. Next naming. So I will start this point as A and this point as B and this point as C. Next I will project the line upward to obtain the first front view of a equilateral triangular lamina. The view that is been obtained by using the projection line will be represented from this point to this point. So this line represents the front view of a equilateral triangular lamina. Next, naming. Because we are viewing from this direction, this point will be a B dash in front view and the point A which is hidden, so it is represented in bracket, so I represent it as A dash. Next the point C will become C dash in front view. Next is what is the next change over position? The lamina makes 45 degree with HP, right? So whatever the angle which is making with respect to HP will be seen in VP plane. So what this view will be represented at an angle of 45 degree. So measure the distance. What is the distance? What is the length of this line? So it is 21.65. So I will mark a point on XY line anywhere I will mark it and I will draw a length of 21.65. Next angle is 45 degree. Yes. Naming has to be done. So this point is been represented by 2 points. One is B dash and another one is A dash. Next this point is been represented by C dash. Next, to obtain the second top view of a equilateral triangular lamina, we have to project the line. So, draw a projection line from this point. Where is A dash? A dash is here and A is here. So, up to there, the intersection point between these two will give the point A dash, mean A on top view. So, from this point to B dash to B. Yes, next from C dash to C. So I got the 3 points and I will join the points to get the top view of a equilateral triangular lamina at second position when the plane is been inclined at an angle of 45 degree. Right. So to measure, you can check here. This is the angle, that is 45 degree. And naming has to be done. So this point is nothing but A, this is B, and this is C. Now, what is the difference between the normal problem and the beta angle problem? See here, in the normal problem, you can see that the distance between this line and this line is one and the same. So, with respect to this, they used to say that it is been inclined at some angle with respect to VP. Whereas, in this problem, they have mentioned one of its median is inclined at 40 degree to VP. So, what is the median? Median is a line which is at the midpoint of a line. So if you consider this line, so this point will be the midpoint, and the line that is been obtained here, that becomes the median. So for this, it is this one. So when I measure the distance, I will mark it. So I will mark this point as D1, D1, and this point as D. So when I measure the distance, C and D1 has a length of 21.65, whereas C and D has a length of 15.31. So at this condition, it comes a beta angle problem because they are mentioning with respect to the median line. So what I do, the line inclination is what? It is inclined at 40 degree to VP, and that will be seen in HP plane. So I will draw a line of some length, but the angle should be of 40 degree. So now this view cannot be directly placed on this line because they are mentioning with respect to the median. So at that condition, what we have to do is we have to cut an arc. So use the compass, measure the distance C and D1. It is 21.65 on this line. Anywhere on this line, cut an arc of 21.65. Now I will draw the locus line. After drawing the locus line, I can extend the line still more. After drawing the locus line, the next step is measure the distance CD1, that is 15.31. So once again go for arc by center point, that is using the compass. You have to cut an arc from the same point where you have taken 21.65. So 15.31, enter. So I will cut an arc. So it is cutting at this particular point. So I will mark the line. Yes. Now I will extend the line. Extend this line. See, you can check here the angle. What is the angle that has been obtained here? So initially we took a line of 40 degree, right? So with respect to 40 degree line, we took the 21.65 length and we cut the arc. Now to get the beta angle, what we did? We took this 15.31 and from the same point we cut an arc of 15.31, and the angle that has been measured, that will be the beta angle. So I will measure the angle. So what is the angle? So it is 65 degrees. So this angle we call it as beta angle. Okay, now we got the point C and D. So this is C. I will mark it. This is the point C and this is the point D. So next what we want to get, I want to get the point A and B, right? So for that, what I do, I will measure the distance from point A and C. From point A and C it is 19.76. Similarly from point C and B it is 19.76. So I will take the compass and cut an arc of 19.76, enter. 19.76. Similarly here also 19.76. Okay, So I have cut an arc. Okay. Next, from point D to A, it is the midpoint, right? The point D is a midpoint. So from A to D it is 12.5. So once again I will use the compass, and from point D I will cut an arc of 12.5. Yes. Next, similarly from point D I will cut an arc of 12.5. So this is the intersection point and this is the intersection point, right? So I will join the line because it is a view. What I do, I will make it dark. From point D only I will take from point D to this point. Next, similarly from point D to this point. Next, join the points to C. So you can see here this triangle has been placed at this some particular angle, and that angle is with respect to beta angle, right? So I will just name it. So this one is point A and this is point B, right? Now extend the line, projection line, right? So point A is here, point A dash is here. So I will extend the line up to xy line. Similarly, point B is here, B dash is here. So I will extend the line up to xy line. Next, remaining is point C, from C to C dash, intersection point. Yes. So draw a line. It should be visible line from point B to C, from C to A, from A to B, and name it. This is point C dash because it is in representing in front view, and this is A dash, and this is B dash. This is how the beta angle problem will be solved. So this is very important while solving the beta angle problem. You should take the difference. We should measure first the difference between this median and this median, and with respect to these lines, we have to draw this equilateral triangle. Right? That is the triangle that will be obtained. It is not an equilateral triangle. The triangle will be obtained, and based upon this, the front view will be obtained. So I think you people have understood. Thank you. Thank you very much.